reminder, your homework, if you're seeing this after Friday, I hope you submitted your homework on Alex. And then your next assignment for F is due on Tuesday before midnight, okay? And it's all in preparation for Wednesday's quiz. I'll check in with you on Monday or so to see how prepared you are for Wednesday. Let's just take a moment to review the difference between categorical and quantitative data. Categorical is when you put into categories, all right? So here's some good examples. These can be displayed in contingency tables or in frequency tables. Okay. Quantitative is what we're going to focus on this chapter. It's when you're dealing with counts and measures. So height, number of eyelashes you have, time, pulse rates, anything like that. Your weight, whatever. Okay. Remember, sometimes these can overlap. Like you can make an argument that some quantitative variables could be like categorical. Like for example, number of siblings that you have, right? Like most of us have, I don't know, on average, maybe, like you could divide it up into 0, 1, 2, 3, and then maybe 4 or more. And those could be categories right there. Since you made that 4 or more, all the numbers 4 and above would just be in that bin of 4 or more, okay? We're going to be talking about 4 types of graphs. Okay. The first one I think you're familiar with is called a histogram, and this is going to be on page 46. Okay. Remember, I'm just following along what's in the textbook. So one of the characteristics of a histogram is like, it's kind of like a bar graph. I think you've all dealt with bar graphs before. And it has these bars. However, one of the main differences is that these bars are smushed together. Okay? There are no gaps in between the bars. And then bar graphs are for categorical variables. Histograms are for quantitative. So let's say, for example, this first bar right here, we'll say is, I don't know, 3,000. And then this one right here is 6,000. And then this one here is like 9,000. And then 12,000. Okay? Now, if you look at this gap right here, you would think that, okay, this is 0, and this is 3,000. But we can make a little symbol to show that we've actually jumped some numbers right here. And I think some of you have seen this. It's going to be kind of like a break like that. Okay? Like that little symbol that kind of goes like that. All right, so that just shows that you skipped. Okay, so make sure you do that. The next thing, I'm just going to overview these and we'll go more into detail later on, is a stem and leaf graph, and this can be found on page 47. So we have two types. We have a regular stem and leaf, and then we have a back-to-back one. Let me show you what the first one looks like. Let's take, for example, we're looking at the number of letters you have in your name. Okay, so let's say you have some numbers like, there's someone in your class has 7 letters, and then there's someone with 14, and there's someone with 3, and there's someone with 21, and there's someone with 16, and then you have an 11, and then you have a 6. That's pretty short. We have a 25 right here. Okay, so we're going to make our stem first. Our stem goes from small to large. So if you look at these values, we want to make it into like 2-digit numbers. So the 7 would actually be the tens place would be a 0, right? So it'd be 0, 1, and 2. And then 0, now you have a 6 and a 7. You have the 6 and you have the 7, so you write 6, comma 7, putting the smallest number close to the stem. So this part represents the leaf part, this part represents the stem. Take a pause, take a look at page 47 for more examples. Okay. And the 1, we have and 11. So I'm gonna put a 1 right here. So this 1 and this 1 combined makes 11. And then, we forgot a 3 right there. Oh my. So there should be a 3 right before that 6. Excuse me. So make sure I don't miss the next one. So the next one should be 14. Next one should be 16. And then we have a 21. And we have a 25. Okay. What you also need to do is you need to make a little key. Your key here is just going to show what these mean. So, for example, like the 0 with the line 6, what that means is simply the number 6. Okay? So make sure you write that key. So look at page 47, 48. Yeah, 47 to 48 for more examples. So this is a regular stem and leaf plot. Now we have something called a back-to-back stem and leaf plot, okay? And this is useful when we're comparing two distributions. Maybe we're gonna go back to the age-old battle of who's better, males or females, right? Males and females. So we'll make a stem here. And let's say, what are we comparing? I guess we could do letters in your name again. So we have a 0, 1, 2. And let's say there's a female that has 24 letters, 26 letters, 28 letters. There's someone with 11. There's someone with 15 letters. There's someone with 17. There's someone with 19. There's someone with 9 letters. And then for males, we could see that maybe there is someone with 14. Now this 1 and 4, this is not 41, okay? Because this is your stem, and you have leaves on both sides. This is 14, not 41. And you always want to go from smallest number is closest to the stem. So we have 6, and maybe we have an 8, and then a 0, and a 4, etc. Okay? And same thing, you want to make a key. So for your key, you can say that 1 with a line 5 equals 15. Okay, so this is a back-to-back stem and leaf plot. This is just a standard stem and leaf plot. Okay? All right, let's go to the next type. We have a dot plot. I think you're familiar with these. Dot plots are found on page 49. And dot plots could either be horizontal or vertical. The example on page 49 they give you, you see right here, excuse me, this would be a horizontal right here. Let's see if they give you a vertical one. No. Back to histograms. Histograms as well could be a horizontal or vertical, but usually you see them as a vertical. Okay. All right. So dot plots could be anything, I don't know, 0, 1, 2, 3, 4, and you just make dots. Okay, it's like how frequently did each of these values appear? Sometimes people like to use X's. I mean, you can use O's if you wanted to. You can do this, you know. Just a quick review. What is this called again right here? The value that appears the most. I'll give you a hint. It starts with the M. Mean, median, or mode. That's right, you guessed correctly. This is what you call your mode. Okay? And the fourth type is a time plot. These, don't worry too much about these. I think you're able to read these. They're kind of like a line graph, sort of. This is on page 57. I won't draw it, but you can look at that, okay? But don't worry too much about those. We're going to be working with the first three a lot more. Okay? Now, how do we describe these graphs, right? Because we're going to be making a lot of graphs this year, and we want to be able to describe it instead of saying like, okay, I don't know, it looks kind of flattish, or this one looks like there's like a peak at 2, or this one the smallest number is 0. We have some language that we want to use. Okay. By the way, how are you guys doing with your language in class? Anyone contribute to the swear jar lately? Anyone need to clean their mouth out with soap? Okay, so how to describe a distribution. Okay, guys, thank you so much. I'm really sad that I'm not there with you guys, but I hope that you're still doing some good work, okay? So we use an acronym called CUS. If you look at some online resources, you might see something like socks, but I'll tell you in a second why I don't like socks. I prefer CUS, okay? So the C stands for center. We're gonna reference page 52 for this. The U stands for unusual features. It's on page 51. And then S stands for shape. It's on page 50. And page 53, can you guess what the last S stands for? Spread. Okay. Center, unusual features, shape, and spread. So when you're looking at a distribution, I'm going to go back to this that we drew right here. If I asked you, what is the center of this distribution? Here. This one's pretty simple, right? You could say, oh, it's 2. However, let's say, I'll draw another dot plot. 1, 0, 1, 2, 3, 4. What would you say is the center of this? You might still be tempted to pick 2 because 2 is the middle number between 0 and 4. However, where would you say the middle is? Okay, maybe 3, maybe 4 even. Maybe it's like 3.5, maybe it's 2.5. So that's what we're going to be talking about here. And there's 2 measurements that we're going to be, or 2 statistics, right? Remember, this is our raw data. And then when we calculate something like a mean or median or even a mode, that is going to be called a statistic. So a center, we use mean or median, okay? And then, not sure if we've gone over this yet, you might have seen this. The symbol for mean that we're going to be using a lot is an X with a line over it. And we don't say X with a line over it, we call that X bar, okay? So we use a mean. We use mean when a distribution is symmetrical, like roughly symmetrical. However, just like this one right here, maybe using a mean may not be, valuable here. So when something is skewed means you have a graph, like this is symmetrical right here. This histogram is roughly symmetrical. It's not exactly symmetrical, but roughly symmetrical. By the way, they say like the most beautiful people in the world, they have symmetrical faces. Most of us don't, we're all beautiful, but most people don't have exactly symmetrical faces. But there's some, they've done these studies on beautiful, quote unquote, beautiful people, celebrities in the world. And those that have really symmetrical faces are the ones that I guess we perceive as beautiful. I don't know, whatever. Oh. That's what we call skewed, okay? All right. So unusual features, we're looking at things like outliers. We're looking at gaps. And later on, we'll go over a term called clusters. Kind of gaps form clusters. Okay, that's when there's a gap in your data. Like if we, oh my gosh, this paper's all the way over there. Say we had something right here, and this number continued 5, 6, 7, and we have something right here. That's 7. That might be considered a outlier right there. This would be a gap. So gap, outlier. Okay. A shape here. So this shape right here, we would call. There's many different types. Look on page 50. So we have unimodal, bimodal, multimodal. You could have symmetric or symmetrical. Okay, and you could have skewed left or right. Okay. And you could also have uniform. And take a look at your textbook, page 50, for examples of those. Unimodals, so modes are like peaks or mountains. Okay? So look at in your textbook right here. This example, here, this would be considered a peak, and that would be considered a peak. And since there are two peaks, we call that bimodal. Uniform right below it is something, it's kind of like a flat top. Okay? It's pretty uniform. The beginning is similar to the middle, similar to the end. Okay? Symmetric, I think you know what symmetric is. And then skewed. So this one right here, skewed is a little complicated because when you say skewed left, it's talking about where the tail is going. A lot of people, when they think this is skewed right because the peak or the mode is on the right side, but when it skews that way, it's skewed left. The tail goes that way. Okay? And same thing for this one. The tail is skewed to the right. The tail is skewed to the left. Oh, you can't even see that. I'm totally off the graph. I'm so sorry. How long has it been like that? Oh my. Oh my goodness. I was just saying skewed left, skewed right. Sorry about that. Okay. And then next, lastly, we're going to talk about spread. Spread right now, all we're using is the range. The range is simply the maximum value minus the minimum value. So your largest number subtracted by your smallest number, okay? Later on, we're going to be using standard deviation and also something called the IQR. So this will be chapter 4 currently right now, and this is just a sneak peek to chapter 5. Don't worry about this, okay? Right now, just worry about range is synonymous with your spread. All right. So the reason why I don't like socks is that O is just outliers. However, we need to talk about gaps and clusters too. So the S is the same, the C is the same, the S is the same right here. But instead of using O, I prefer U for cuss. All right. Guys, I wanted to show you something. I actually, remember I told you I got my my cyst. They let me keep it. I don't know if you guys can see it. Let me open it up for you guys. Can you see that? Okay. So yeah, that's my cyst that they took out of my knee the other day. Oh shoot. Oh gosh. Okay, let me just turn this off. Sorry guys.